why they are shaped that way? The answer lies in one of the most fascinating pieces of industrial equipment, the distillation column. Distillation columns are widely used in industrial like oil refining, chemical manufacturing, and even in producing the spirits. But how exactly do they work? How can they achieve such precise separation? In this video, it will show the distillation columns and its application, which include the definition, key principles, and also the operation process of distillation. It will also include a simple demonstration of the distillation process and the application of distillation in real life. Alright, let's dive into principles behind the distillation and explore the design and operation of distillation column step by step.
Next, we will go into the definition of distillation. One of the widely used separation technique for liquid is distillation. Distillation is a separation technique that relies on the different in boiling points to separate components in a liquid mixture. So, it involves heating the mixture to create vapor, and then vapor will form a liquid in a cooling process. So, this will isolate one or more component. And then, distillation also finds its greatest application in the large-scale separation of liquid mixture, as in petroleum refining plants. Next, we will talk about the key principle of distillation. The first one is difference in boiling point. The separation process of liquid mixture is mainly based on the component's boiling point. So in the distillation process, those substances with the lowest boiling point will steam first and escape from the surface. And then the liquid, the distilled liquid, which is known as distill, will be collected at condenser. The next key principle is about the phase change. In this distillation, we have two main phase change, which is the first one is vapor to liquid and the second one is liquid to vapor. And then the last key principle is about separation and also repetition. For us to achieve a maximum purity in distillation, a multiply cycles is needed. So, in order to separate the mixture and increase the amount of chemical component, each cycle need to go through the theoretical cycle. So, this method is suitable when we use a fractional distillation column. Next, we will look into the factor affecting distillation column. The first one is about the feed condition, which involve the boiling points. So from the previous subtopic that we have discussed, at the feed, mixture will go into the distillation with a different kinds of physical properties such as boiling point. Therefore, a higher boiling points will have a harder separation due to they need more stages and also higher reflux ratios. So the second factors is about column design, which involve diameter and also height and number of stages. For diameter, the speed of flow will depend on the column diameter. So we need to choose the right size of diameter for the column to operate successfully. And the second is about height and also number of stages. Suitable height and sufficient number of trays are needed for contact stages to produce an effective separation. The third factor is about column material, which we will talk about the trays and also packing. So tray efficiency are affected by falling, wear and tear, and also corrosion. So we need to choose the appropriate material for the column to operate nicely. The fourth factors is liquid flow rate, which will talk about the vapor and also liquid flow rate. So the stable flow rates will prevent operational issues like flooding or weeping. So this will ensure an efficient mass transfer and also column stability. And the last one is about operation condition, which we will talk about the temperature and also pressure. As for the temperature, appropriate temperature must be maintained throughout the column to achieve a desired separation. And also for the pressure must be adjusted to optimize the separation process, especially for temperature sensitive components.
Hello guys, this is for a simple demonstration of distillation. For the first part is feed introduction. The mixture is introduced at the feed tray. It typically enters in liquid form, but it can also have some vapor depending on the process. Next, for heating and vaporization, the boiler heats the liquid at the bottom, generating vapor. This vapor rises through the column. And for the rising vapor and falling liquid, as a vapor rise through the tray or the packing, it will cool slightly. Component with higher boiling point condense into liquid and flow back down. At the same time, liquid on the trays absorb heat and partially vaporize, sending lighter components upward. As you can see, for the condensation, you can see the main condenser. The vapor reaching the top of the column enters the condenser. Here, it cools down and turns back into liquid. This liquid, called the distillate, is collected as the lightest product. And for the last part, you can see this is overview the distillation. So for product collection, different fractions are collected at specific point along the column. For example, the top, lightest component, for example like gas, and medium boiling fraction like kerosene or diesel. And the last one is bottom, heavy component like oil.
Advantages and limitations of distillation. Let's start with the advantage. First, effective purifications. Distillations effectively purify liquids by removing non-volatile impurities or isolating specific components. For example, it widely used to produce distilled water free of minerals and contaminants. Second, precision with fractional distillation. For mixture with close boiling points, such as ethanol and water, fractional distillations provide precise separations by utilizing repeated cycles of vaporizations and condensation. Third, recyclability. Distillations enable the recovery and reuse of valuable liquids, such as solvents, reducing waste and operational costs. However, distillation has some limitations. First, isotopes. Certain mixtures, like ethanol and water at 95% ethanol, form isotopes cannot be fully separated by simple or fractional distillation, requiring advanced techniques. Second, environmental concerns. Large-scale distillations, like in oil refining, can contribute to greenhouse gas emissions if powered by fossil fuels. Finally, time consumption. Distillation is often a slow process, especially for large volume or high purity requirements. Distillation is a versatile and effective process with notable limitations that must be considered in specific application.
Next, we move to the application of distillation in real life. So there is a two most common application in distillation, which is water purification and oil refining. So water purification in distillation is a process that involves heating water to its boiling point, then collecting and condensing the vapor back into the liquid form. This method effectively removes impurities such as salts, heavy metals, and microorganisms from the water. So for the second application of distillation is oil refining. Oil refining is a key process in petroleum industry to separate crude oil into its various components based on their boiling points. This process, known as fractional distillation, is used to separate crude oil into different fractional that have specific uses, such as gasoline, kerosene, diesel oil, and fuel oil.
In summary, distillation is a separation technique based on different in boiling points. It works by heating a mixture to vaporize its components, then cooling the vapor to collect it as a liquid. This process effectively isolates and purifies the substance, as we demonstrate here. Distillation has countless applications, from water purification to refined oil, and this making it a vital tool in science and industry. Thank you for watching. Don't forget to like, share, and subscribe for more educational videos. See you next time.